Chebyshev's and other theorems give us insight into how the values of a random variable are distributed about the mean. This motivates the coefficient of variation. Let x be a random variable with mean mu and standard deviation sigma. The coefficient of variation is the ratio between sigma and mu. Should we worry that mu is our divisor? Generally speaking, no. In ratio data, the mean can only be 0 if all values are 0. But what if we have interval data? In interval data, we can usually identify a natural 0 and make our values into ratio data. For example, if our data is temperatures in degrees Celsius, we can convert our data into temperatures in degrees Kelvin. For example, suppose we have a sample of weights with mean 24 and standard deviation 4 kilograms. Find the coefficient of variation. That's the ratio of the standard deviation to the mean, which will be we could be given the cumulative distribution function. And note that this is the cumulative distribution function for an exponential distribution with parameter 1/500th. Remember that for an exponential distribution with a parameter, the mean and standard deviation is the reciprocal of that parameter. So that gives us the mean and standard deviation. And so the coefficient of variation is the quotient. Since the mean and standard deviation of an exponential distribution are always equal, this means that the coefficient of variation of any exponential distribution will be 1. We can also work the problem backwards. Suppose we have a random variable with a Poisson distribution with a coefficient of variation 0.1. Let's find the most likely value or values of our random variable. So for the Poisson distribution, remember our mean is whatever the parameter is, and our standard deviation is the square root of the parameter. We're given the coefficient of variation, and we know that the mean is the parameter, the standard deviation is the square root, and so we find So remember that for a Poisson distribution, the modes are the parameter and the parameter minus 1. So the most likely values of our random variable will be 99 and 100. Or suppose we have two random variables, and assume they're independent with the same mean, where we have coefficients of variation, say 2 and 5. Let's find the variance and the coefficient of variation. Let mu be their common mean. Then we know that the ratio of the standard deviations to the mean are 2 and 5. And that allows us to express the standard deviations in terms of the mean. And remember, the variance is the square of the standard deviation, so we can find the variance of x and the variance of y also in terms of the mean. So first we'll find the mean of our random variable. That's just the expected value of z, and the linearity of expectation allows us to rewrite this as, and so we find since the two are independent, the variance is going to be, so we can remove the constant factors as the squares of those factors. We know the variances. Substituting those in gives us the variance of z, and the standard deviation is going to be the square root, and the coefficient of variation will be